Hi, welcome back to our Honors Geometry series. In this video, we're going to look at the exterior angle inequality, which says that the exterior angle must be larger than the measure of either of the corresponding remote interior angles. So if I had theta, theta, alpha, beta, or theta alpha. There we go. So theta must be larger than either of these two. So theta larger than either one of those remote interior angles. And how do I know that? Well, I know that because if I put some numbers in here, let's say this were, I don't know, 110 degrees. Well, this would be 70 degrees, and maybe this is, I don't know, maybe that's 90, and that's 20. Well, no matter what it is, because these two must add up to make 110, you know, you could think of like 2 plus 5 equals 7. Well, these two must be less than 7. Or x plus 13 equals 25. I don't, maybe I don't immediately recognize what x is, but I know it's got to be less than 25. And the reason why it has to be less than 25 is because if it were equal, my triangle would collapse on itself. So your exterior angle must be greater than either remote interior angle. Let's look at angle 1. Here's my triangle. My remote interior angles would be there and there. So angle 1 must be greater than angle 8. Okay, and I can kind of change what triangle I'm looking at here. So there's another triangle. Those are my remote interior angles. 1 must be greater than angle 2. It must be greater than angle 3 as well. All right, let's look at this other triangle here. Must be greater than angle 5, because here's a remote interior, there's a remote interior. All right, let me change colors here. Measures less than angle 9. There's an exterior angle. All right, let's go biggest triangle first. That's a remote interior. No other remote interiors, so that doesn't really help me a whole lot. Let's look at this triangle here. That also really doesn't work because that's a split up remote interior, and that's not a remote interior that we know. But this one gives me 7 and 6. Angle 7, angle 6. Now you could make a case that 9 is greater than 8, but you could also make a case that that's not to scale, or maybe that's just a fluke of the drawing. Maybe it was an inaccurate sketch of the situation. Because it is possible for a linear pair, I could have an exterior angle like this one, where my exterior angle theta is smaller than alpha. So that's possible. So I can't quite say that 8 is smaller than 9, even though it definitely looks smaller. I'm not going to make that claim. All right, angle 5. See, like here, 5 is an exterior angle, just like what we talked about a second ago. For that triangle, for this triangle right here, 5 is an exterior angle. But 6 is bigger, or at least 6 looks bigger. But I know that 5 must be greater than either 7 or 8. Okay, but this asks me for measures greater than 5. Well, what is 5 a remote interior angle to? We know that it's a remote interior angle to angle 1, exterior. There, 5 is a remote interior angle. So angle 1 is one of them. There's also angle 3, which is kind of interesting. There's an exterior angle at 3. So I can say that 3 must be larger than 5. And I'm not sure I can say any other angles for sure are going to be greater than 5. Angle 8, what is 8 a remote interior angle to? Well, it's a remote interior angle here to 5. So 5 must be bigger. 8 is also a remote interior angle to 3. And is it a remote interior angle to 1? So there's a quick video on our exterior angle inequality. Let me know what questions you've got, and I will see you soon.